Okay, today we're talking about problems 166 through 173. 166. Given a jar with 4 marbles, 3 red and 1 white, what is the probability of a red then a white? That's what that means, by the way. I know for some of you, you're not sure what this actually meant. It was probability of a red and then a white. Now what they say next is really important. Given no replacement. That means, now let's picture this. Okay, so we've got this jar, and we got 3 red ones in there, and 1 white one. White's kind of hard to draw. I'll just make it empty like that, okay? So that's going to be a white one. And we're trying to figure out the probability that I will get a red one, and then not replace it, and then get a white one. All right, well, first of all, what's the probability of getting that red one? Well, there's how many total marbles in there? There's 4. So the probability of getting the red one would be 3 out of 4. And I times that by, what's the probability that I'm going to get a white one next? Well, remember, there were 4 in there to start with. But if I actually got a red one, then there are only 2 red ones left and 1 white one, which makes 3 marbles total in there. Okay? And what's my probability of getting the white one? There's only 1 white one out of 3. And then compound probability, you multiply your probabilities together. So I'd have this times that. Well, luckily, I know how to multiply fractions. So I'd like to cancel these 3's and make them into 1's, because 3 divided by 3 is 1. And now I'll have 1 over 4 as my final answer. Okay, anytime you are doing a problem like this, you have to especially watch for whether or not there's replacement or not. And when there's no replacement, then you've got to say, okay, well, there's on the second time around, the second time you draw a marble, there's going to be less marbles. And so therefore, it's not out of 4 anymore, it's out of 3 marbles that are left. Okay? All right, that's how you do that one. Let's move on to some more probability. Given a coin is flipped and a die is rolled, what is the probability of H, 3? That means getting a heads and then getting a 3. Well, these are obviously independent of each other. The other one could be called dependent, where you were drawing a marble out and then that changed the probability of the other marble. This one, though, is independent because the coin, once it's flipped, isn't going to affect the die at all. Okay? So independent probabilities like this, you still multiply them, but the thing is that they don't change each other. All right? So what's the probability of a heads? Well, that's simple, 1 and 2. And the probability of getting a 3? Well, there's only one of those out of 6 things are possible. Okay? And so I'm going to multiply those together, and I will get 1 times 1 is 1, over 2 times 6 is 12. And so I have a 1 in 12 chance of getting a heads and then a 3. All right, so that's my probability. Moving on. In which does order matter? Permutation or combination? I don't have a snappy way for you to remember this, but I can tell you that it's permutation where order matters. Okay, and combination, order does not matter. Okay, so those are the 2 major ways we do problems with in this area, and that's permutations and combinations. Permutations, order matters. In combinations, it doesn't. All right, next. Set up a 9P2 for a race with 7 runners in 3 places. Okay, well, this is just an example of one, and they're saying to do either a P or a C, and then a number in front and a number after it. Well, first of all, this is a race with 7 runners in 3 places. A race implies that you've got places in like order, and the order matters. Remember what we were saying on that permutation combination thing? If order matters, then you want a P, a permutation. And then the first number you have is how many are competing, I guess you'd say. So if there's 7 runners, I'm going to put my 7 there. The number after the P is how many places you're giving out, or how many spots there are, okay? And that's 3 in this case. So it'd be 7P3. And it's outside the purview of this video to try to explain exactly how to get that. I can at least tell you on the calculator there is a permutation button. It's under the math key. And so you'd want 7P3 for this one. Okay? Next, set up a one of those kind of deals, 9C2 or 10P3 or whatever, for a committee made up of 3 people chosen from 20. All right, in a committee, order doesn't matter. If you're on the, the party planning committee, okay, it really doesn't matter if you're, there's not like a boss of the committee, I suppose. There could be, but when you're making a committee like this, we assume order does not matter. If order doesn't matter, we do use a C. And that stands for a combination, not a permutation. Okay, now, how many are there to choose from? 20 people. And how many spots are there? 3. So we do 20C3. And that, again, is a calculation that you can do on the calculator. And that's all I'm going to explain about that for now. Moving on. Set up one of those. If there are 3 types of meats and 4 kinds of cheese, how many pizzas can be made which have 1 meat and 1 cheese? All right, this type of a problem is made up of multi-parts. Okay, basically we have meat and we have cheese, and we're going to multiply them together to get all of our options for meat and our options for cheese multiplied out. All right, and we're going to assume in this situation that the order that it goes on doesn't matter. Because you don't get a pizza and then say, hey, you put the pepperoni on top of the sausage, and that's completely out of line. You know what I'm saying? So the order does not matter. So therefore, we use a C and a C. And then for our meats, how many do we have to choose from? Well, if there is 3 types of meats, then I have 3 to choose from. And I want 1 meat. So I want to have 1 spot for that. Okay? 3 kinds of meat, and I choose 1. And then cheese, there are 4 kinds of cheese, so 4 kinds of cheese, and I'm going to choose 1. So 3 choose 1 times 4 choose 1 would give me my total number of possibilities, okay? You multiply your possibilities to get all of your possibilities, all right? Multiply your options, I guess you'd say. All right, moving on. Set up a 9C2 in a 5-card game with a 52-card deck. What's the probability of 3 kings and 2 queens being dealt? All right. All right. So first of all, it's not being dealt ever, because that would be different. But if I'm just dealing out one hand, to me, what's the probability I'm going to get 3 kings and 2 queens? All right. Well, the way you figure this out is it's a probability question. So I have to have all the things that are possible on the top all the things that are possible on the bottom and what I want on the top. All right, that's the general thing for probability is all the things that are possible go down here and all the things that I want go up here. Okay, the favorable outcomes, sometimes they say. All right, all the possible outcomes would be there are 52 cards, and I'm going to choose 5 of them. Okay, so it's a 5-card game, so I'm going to get 5 cards. So here's how many spots I have, and here's how many things are possible. All right, so 52, choose 5 goes on the bottom. On the top, there's 2 things we're talking about, kings and queens. And how many kings are there in the deck? There's 4, and I want to choose to get how many of them? I want 3 kings. Multiply your possibilities, all right? And with the queens, there's 2 queens. Well, there's 4 in the deck, and I want to choose to get 2 of them. And the last thing that sometimes teachers will put in here is something to make the equation balance. I've already talked about the kings and the queens, and that's 8 of the cards in the deck. That leaves 44 cards left. So I could say times 44, choose 0. But that's just to make it balanced, because in this type of problem, you may remember doing these, that and that and that have to add up to this, and this and this and this have to add up to that. Okay, so I can double check to make sure I did it right by checking those things. All right, so that's a complicated probability question. You'd use a calculator to figure out 4C3 times 4C2 times, that last one is just 1, okay, because it's a definition thing, because anytime you choose 0, there's only one way to do that. All divided by 55, choose 5, and you'd come out with a very small probability of that happening. All right, one more on this little video. Just set up the binomial for this. Jim has an 85% free throw average. In 4 shots, what's the probability of missing exactly 2? Okay, well, if they want a binomial, the binomials kind of look like this. Something, see something, and then 2 sets of parentheses. Okay, this is meant to just be a review for you. Hopefully you've learned this over the course of a whole day at school, but a reminder, this is out of 4 shots. So there were 4 shots, and I'm going to choose to have them make or miss exactly 2, because there's 4 shots, so he's going to make 2 and miss 2. So I'm going to call these the makes, and this is the misses. And I'm going to say, out of 4 shots, I want him to make 2, and the probability of making it is 85%, making one of the shots anyway. And the probability of missing then is 15% chance. And then I want him to make 2 and miss, well, if he's going to make 2, he must miss 2. So there it is. I'd multiply that out, and it would tell me the probability that this would happen. Okay. Another example would be, let's say somebody's a 60% field goal kicker. Okay, he makes it 60% of the time, and he gets 3 chances to kick field goals. That would be 3, choose, and let's say the probability of making all 3. Well, you'd say 3, and I'm going to choose to have him make 3, and this would be makes, and this would be misses. And the make probability is 60%. The miss then must be 40%. Those always have to add up to 1. And then I'm going to say, if I want him to make 3, I'd have a 3 here. And if he's going to make 3, that means he's going to miss 0. You get that? And so bottom line is you'd find that on your calculator, which is really easy, and then that. And then anything to 0 power is equal to 1, so just times by 1. And that's how you